Okay, so I want to acknowledge that I'm joining and greeting you from the unceded, occupied territories of the Musqueam, Squamish, and Tsleil-Waututh Nations in what's known as Vancouver. I know you're coming from different regions, and I encourage you to find out whose traditional territory you're on. Through the course of the series, I encourage you to think about whose land you're on, what communities you're serving through your work, and how you can support Indigenous initiatives and work to benefit Indigenous people and the lands that we live and rely on, and be grateful for the continued and historical care that these nations have given the land, air, water, and soil since time immemorial that we all enjoy. I'm also going to share a link to an article highlighting the work of Dr. Jennifer Grenz, who's a professor at UBC and an Inkimik woman. Since today we're talking about our relationships to pests and beneficial insects, I thought it would be an interesting article to share because although it's not about pests, Dr. Grenz speaks about Indigenous ecology and the role of humans in contributing to thriving ecosystems through our relationships to plants and soil, etc. So I'll just share this in the chat as some food for thought for you to check out later. It's just a few minutes read. It's very short. So I'll share that. And also because it's Black History Month, I wanted to share an article about Black history in BC. It's kind of talking about the lesser known, like middle part of Black history. We know a lot about kind of early communities and present day, but a lot of times the whole missing history of Black communities in BC is missing. So it's also a pretty short read, and I'll just leave that for you to look at if it interests you later. For those of you who aren't familiar with SPEC, we work to develop practical solutions for urban sustainability, and we're a charity that was founded in 1969. We work on areas of food, energy, transportation, waste, and climate change, so pretty diverse programs at SPEC, and then one of them is the Farmland Ecosystem Services Program, which you're aware of. Today we're speaking with Bonnie Zand. Bonnie is the owner of Bonnie's Bugs IPM, a private insect consulting company. She's been helping Vancouver Island growers with their IPM management for over 10 years. So we're really stoked to have Bonnie. She's currently running the Vancouver Island Pests, Pollinators and Beneficials Project, and is a board member of the Native Bee Society of BC, which if you're not aware of, it's a really cool organization. I encourage you to check out. And Bonnie's also an instructor of the Master Melittologist program. So without further delay, I'm going to pass it over to Bonnie. And remember that you can ask questions during the presentation. I'll be monitoring the chat, but we'll also have time at the end as well.
Thank you, Teresa. I'm thrilled to be here, thrilled to see a bunch of people interested in learning how to improve their pest management and encourage their beneficials. I will share my presentation. Just give me a moment to pull this up. All right, so I'm Bonnie. I'm coming to you from the traditional territory of the Comox First Nation in Fanny Bay, Vancouver Island. And I am going to talk to you about managing your pests and beneficial insects using a system called Integrated Pest Management, or IPM. And one of the things that often happens at this time of year is we are in kind of a retrospective phase. We're looking back over our last season, thinking about our next season. There's a lot of excitement. I know I was looking through my seeds yesterday. But there might also be some concern as we think about some of the pest issues we faced in the past and pest issues we might be facing in the future. And what often happens when farmers are thinking about pests is that this image on the slide tends to be what we think about. Going out to harvest our prize-winning vegetables and finding a big fat caterpillar in there wrecking our harvest. And we tend to have a very narrow focus where we're really looking down and saying, that caterpillar on that plant, how do I kill it? And that's the question we ask. What can I do right now to kill that thing? And well, that's an important question. What I want to talk about today is changing our focus. And so instead of having this narrow tunnel vision on how do I kill that caterpillar that I just found while I was harvesting, instead I want us to broaden our focus and be backing out and looking at the bigger picture of our farms and starting to think of our farms as ecosystems. And so if we're thinking of a farm as an ecosystem, on that farm, we have our plants. And of course, we have the pests that are impacting those plants. But what else is present? There's a lot of external factors on our farms that we don't have much control over. So things like how hot it is, how cold it is, how much rain do we get? Are we going to have a heat dome this year? Those are things we can't really control, but they definitely impact both our pests and our plants. As well, our plants are growing in soil. And we could do an entire talk just on different properties of soil, different types and textures and nutrients and all of the life that's in the soil. And that soil impacts how your plant grows and impacts your pests. There's lots of other insects on your farm that are not your pest insect. And so we need to be thinking about how they are interacting with this entire system. And there are many other plants in the system, both different crops that you're growing, weeds, things in your surroundings. Maybe you're next to a forest, maybe you're next to another farm, all of the other plants in the landscape. And then also, as part of this ecosystem, we have the farmer. And you are a part of your farm ecosystem. And the management strategies that you use can change things, and they can impact your plants, they can impact your pests, and they can impact all of the different things. And so when we're trying to manage a pest, we need to think beyond just this one pest, this one plant. And instead, we need to be thinking about how everything is interacting and depending on everything else. And how can we as farmers try to tilt that balance? And the name of the system that farmers and gardeners use when they're using this ecosystem thinking is called Integrated Pest Management, or IPM. And so when you're farming from an integrated pest management system, there's 6 steps that you want to be thinking about. So the first step is prevention. Do I have healthy plants? Do I have healthy soil? The second step is monitoring. You want to know, do you have a pest problem? Step 3 is identify. What is the pest that's causing your problem? Step 4 is biology. What is this pest doing? What is the life cycle? When is this pest susceptible? And how many pests are too many? Step 5 is control. And that's often where we jump to first thing. How do I control the pest? And when we think about control, I want us to think about physical controls, cultural controls, biological controls, and also chemical controls. And I'll talk more about all of these things. And step 6 is evaluate. Did my control work? And right now, winter is a great time to be doing evaluation and thinking about how things went last year, how the controls you did put in place functioned, and what things you need to change. So the first step in IPM is preventing pest problems in the first place. And our real cornerstone of this is healthy plants. Plants that are stressed, either due to weather conditions, too much sun, too little sun, too much rain, too little rain. Maybe they're at the edge of their cold hardiness zone. Those stressed plants are going to have more pest issues. Plants that are not being provided with appropriate nutrition will also have more pest issues. And this can be either too little nutrition creating a stressed plant, or too much nutrition. If we provide our plants with excess amounts of nitrogen, this actually causes them to put on a lot of really lush growth that's very attractive and susceptible to some pests, such as aphids. And so the better job we do at making sure that our plants are as healthy as they can be, the less pest pressure we're going to have to deal with. It doesn't mean that you won't ever have a pest, but just that the issues will be less. Another thing to think about, depending on what type of plants you're planting, are resistant plants. If you can plant things that resist a disease that you know is present, you're stopping yourself from having to manage that disease later. And so the big thing I want you to kind of take away from here, thinking about prevention, is that sometimes pests can actually be symptoms of other problems. And so if you have a healthy plant, it will be able to produce compounds in its leaves that both decrease plant feeding on it, make the plants less attractive, and those healthy plants are also able to produce compounds that actually call in beneficial insects, so that when they are under attack, they're better able to bring in helpful other insects. And so keep your plants as healthy as you can. But even if you're doing your best with keeping your plants healthy, you will still have pest issues. And so it's very important to catch those pest issues when they are small, before they become big issues. And this is especially true in organic systems. You don't have a lot of really hard-hitting chemical sprays that you can go in and rescue an infested planting. You really need to be catching these things when they're very small. The monitoring methods you use will vary with the crops and with the pest. And just paying attention throughout the year, making a point of going out, looking at your plants, seeing what's going on is really important. For some pests, we have particular targeted trapping methods. And so here on the screen, can you see my mouse? Teresa, can you see what I'm pointing to? No, okay. Now? Yes, okay. All right, so I'm just gonna point to some of these trapping methods. So the one I'm pointing to here, this is a trap for spotted-winged Drosophila, which is a pest of berries. And so it's baited with apple cider vinegar, and the flies come to it and we can find them and look at them. This is a yellow sticky card. And so these are used for monitoring things like carrot rust fly. And so this is where this one is. It's out in a carrot field. The flies will fly in, they'll stick to the card, and then you can go and you can look and see what's present. They're also used in greenhouses to kind of keep an eye out what's happening in the greenhouse. This white one here on the pear tree, this is a trap for codling moth. And so it uses a pheromone, which is an insect sex chemical, to call in the male moths. They fly in, they stick in the bottom, and it's easy to go and count them. And then here we have an apple maggot trap. And so this is a visual trap. It mimics a ripe red apple, but it's coated in tanglefoot. And so when the flies fly, thinking it's an apple, they do it. Again, we can go and look and see what's there. For a lot of other pests, we don't have a really specific trapping method. And instead, what we do are field walks. We go through our farm, we try and do it on a regular schedule, once a week, and we look closely at our plants, looking inside flowers, under leaves. And you can do this sort of monitoring walk at the same time as you're checking other things, looking for irrigation issues, checking for nutrient or disease symptoms. And right now, a bunch of you are probably out pruning. And so while you're pruning is another good time to be doing some monitoring and looking and seeing what sort of pests you've got. And so it's really important to spot problems while they're small and young and susceptible. And so this is the sort of thing you might see if you were out doing a field walk and monitoring a crop. So we've got cabbage here. And so the first thing you can see is there's a lot of symptoms. There's some kind of pest going on here. So we can see all these holes in the leaves and the raggedy leaves. And so that tells us we need to look more closely here. There's clearly something going on. And as we look more closely, pulling those leaves apart, looking down between them and looking under them, we're going to start seeing more symptoms. And so here we've got some poo, big, fat, green poo. So clearly something is in here chewing. And if we look even more closely, we may find the caterpillar. And so you can see it's very camouflaged. And this is why we really need to look closely. So this green velvety caterpillar is creating this damage. But unless we look closely, we'd never see it. And if we're looking even more closely, you may be able to see some of these little tiny eggs. So you can see it next to my finger to give you an idea of the size we're looking at. And these are typically found on the underside of the leaves. And so where you're seeing them, they're orange, they're sort of rocket ship shaped. And when you see those eggs, you know that there will soon be caterpillars. And so this is really where we're trying to get to, is seeing that the pest is going to become a problem before we're seeing all of the holes in the leaves. And another thing that you might see during your monitoring is this beautiful white butterfly flying around your farm. And so this is the adult life stage of that caterpillar. And so when you're seeing the cabbage white butterfly flying, that's again another hint, oh, I should be thinking about caterpillars in my brassicas, because this adult will be laying these eggs that will hatch into these caterpillars that will chew holes in your plants. And so this is the sort of looking we want to be doing. Really close, really intense, checking things out. Once we find something while we're doing our monitoring, we move into step 3, identification. And this can often be the most difficult part of this whole process. Insects are very numerous, very varied, very diverse. It can be really hard to figure out what you're looking at, especially if this isn't something you do frequently. So I've got some tips that you can hopefully use. And so one is that pests tend to be slow moving with downward facing mouth parts that are often camouflaged or hidden in plants or soil. And they're often numerous. So if you find only one of something, chances are it's probably not a pest. But if you find 100 of something, then it definitely may be. And so we can see I've got some examples here. Here's an aphid, and it does have legs, but they're very spindly. If you watch these, they move, but they move pretty slowly. You can see it's got a downward pointing mouth part right here, that little stick pointing down. And it uses that to stab into the plants because it's feeding on the plants, feeding on what it's standing on, sucking the juices out of the plants. This is a leaf roller caterpillar. And so again, really small mouth parts. You can't even really see them. And it's hidden. It's actually wraps these leaves around it and webs them together so that it can feed undisturbed inside the plants. And this one is a root weevil. And so we do have mouth parts here, but again, they're very small, very hard to see. This doesn't really have any legs that you would actually be able to see. And where you would find this is in the soil, actually in the crowns of plants like strawberries, where it's chewed its way in and it's just staying there inside the root crown, chewing. And so all of these are things you can be looking for and thinking about when you're looking for pest insects. Beneficial insects, on the other hand, tend to be faster moving. They tend to have forward-facing mouth parts, and they often have bright colors. They're not nearly as camouflaged. And so I've got some examples of beneficial insects here on this slide. And we actually break our beneficial insects down into 3 categories. So category 1 is predators. So these are insects that are actively going out, chasing down and eating other insects. And so some examples of predators would include things like this bald-faced hornet that catches caterpillars and takes them back to its nest to feed them to its young. This lady beetle larva is a predator. And so you can see it's got strong legs here. And if you watch them, you'll see that they're quite mobile. And so they are going to be pursuing and eating aphids. This is a lacewing larva. So again, you can watch these and see how quickly they move. And it's actually got these beautiful long pincer jaws, and it's got an aphid stuck in those pincer jaws right now, forward-facing jaws. And this is a ground beetle larva. And so here again, this is a really good example of a forward-facing mouth parts. So you can see that this thing looks like it is chasing other insects down and grabbing them. So these are all examples of predators. We also have parasitoids. Parasitoids are the beneficial insects that often get missed when we are looking in our garden. They're often very small. And what a parasitoid does is it lays its egg inside of another insect or inside of the egg of another insect. And its young goes through its entire development inside that other insect, killing it in the process and then coming out. And so, as I'm sure you can understand, in order to do this, the parasitoid needs to be smaller than the host insect. And so a lot of these are wasps. So this is an example of a tiny, tiny wasp. Here's another one. And so this wasp is on these stink bug eggs, and it's going to lay its eggs inside the eggs of the stink bug, and they'll develop there. And so these are very important for biocontrol, but they're often overlooked. And then the final category are pollinators. And so pollinators are, of course, super important for our farms because they are what allows us to grow fruits. A lot of our vegetables that require pollination, like tomatoes, cucumbers, squash. And so it's very important to have a good population of pollinators. And so I've got a bumblebee here. I've got a small sweat bee here. And I also have this hoverfly. And so these are bee mimics, and they're excellent beneficials. The adults are pollinators, but the larva of the hoverfly is actually an aphid predator. And this is a pattern we actually see quite commonly with our beneficial insects, is that some life stages of those insects are often flower feeders. And we can see that here again with this bald-faced hornet, which, while it is finding and eating caterpillars and taking them to its young, is also feeding on flowers. And I'm going to talk a lot more about flowers as we go along. So that gives you some ideas, but it's not really enough for you to be able to see something on your farm and know what it is. And so I've got an app that I use here, and I wanted to kind of run you through how to use iNaturalist to help you with identifying things you might find in your farm. So this is a free app. You can have it on your smartphone. It works with Android or Apple. You can also use it on your desktop and just take pictures with your regular camera. And so I'm going to talk both about a specific iNaturalist project that I run, the Vancouver Island Pests, Pollinators and Beneficial Insects Project. And I'm going to take us to iNaturalist and show us some of the examples there. But first, I just want to run you through the process of adding an observation to iNaturalist and how you would use this. So the first thing that happens, of course, is that you are out on your farm, you move some leaves, and an insect dashes out and runs past. What you want to do is take a picture, and you try and get the least blurry, most zoomed in picture you can, but that's not always super possible. Insects can be fast. Do the best you can. So we have our photo, and I do this on my smartphone. So these are all pictures of the smartphone app. So I want to know what this insect is. Was it a friend? Was it a foe? I'm going to open up the iNaturalist app on my phone, and there's a button that says observe. So I'm going to click on observe, and I have the option to choose how to add an observation. And I'm going to add from my camera roll. You could also take a picture directly within the app, but I'll add from my camera roll. It will open up my camera, all the recent pictures, and I select the picture I want to add. So here's my kind of blurry photo. You can choose up to 4 pictures, and you can actually add more later. I've just got one here. I'm going to hit add, and it's going to create this little observation. So we have the photos. It says, what did you see? And because I have GPS enabled on my phone, it's going to pull up the location that I was at when this picture was taken. And I actually took this picture in North Cowichan on last Friday, February 2nd. And so it's going to pull that information and let us know what's going on there. Now, if I want to find out what it is, I'm going to click here on the what did you see field. And when I click there, if I know what it is, I can type it in. But if I don't know, all I have to do is click on what did I see, and iNaturalist will come up with some suggestions. And so without me inputting any information, iNaturalist suggests that this may be genus Carabus, worm and slug hunters. And then if I scroll down, it's got a couple more suggestions. And so if I want to know more about this suggestion, I can click on the I button, and it'll pull up this little blurb on genus Carabus. We'll have some photos, much better photos than my blurry one. So I can look and see if I think it matches. And I can read this little blurb. And right here at the bottom, as you're reading it, you're going to see it says, these are nocturnal predatory beetles that feed on snails, earthworms, and caterpillars. Okay, so that's great. This is a predatory beetle feeding on snails, earthworms, and caterpillars. That seems like something you should probably not stomp on. And as a matter of fact, you probably want to have more of these. So right away, you've got that answer to your question, kind of what might this be? So you can say, yep, that looks like it matches, and choose genus Carabus. And we're back here at our little input form. You can add some notes. If you have anything else you want to say, maybe about what it was doing, or some reminders for yourself. You can also have the option to change your geo-privacy. So if you don't want everyone to know exactly where you were when you took this picture, you can just change that to obscure, and it will report it from the general area, but it won't tell people exactly where it is. So you do have privacy options. And then down here at the bottom, one more option, and you don't have to use this, but I find projects to be very helpful. You click on projects, you can add this observation to a group of other observations that we call a project. And it'll open the project window, and all the projects that you are a part of will come up. And I'm a part of the Vancouver Island Pests, Pollinators and Beneficials Project. So I'll tick that button. And the way that this particular project is set up is we ask for a few more pieces of information. So we ask what sort of a farm this observation was made on, what type of a crop, whether it's organic or conventional, and a spot for some notes. So you fill in all of those things, and this observation is added to iNaturalist. And I am now gonna swap us over to iNaturalist and show you what it looks like there. So I'm just gonna stop the share for a second, and I will share my other screen. Okay, so can we see my screen? All right. So this is the Vancouver Island Pest, Pollinators and Beneficials iNaturalist page. And so anyone can come here and see it. The URL is along the top, and it is also on my last page. I'll kind of send you there. And so this is all the observations that have been added to this project. These are all from Vancouver Island. So anyone who's on Vancouver Island is welcome to add observations to our project. And you can either add them right here through the desktop, or as I was showing you, using your phone right from the field. If you're not on Vancouver Island, you might need to create your own with farmers in your area. And so there's some things that we can see here. So it tells us we have a total of 1,512 observations in this project. Those observations constitute 398 species. So those are all of the different things that farmers have found on Vancouver Island on their farms. And you can see which species have been observed the most frequently. The Asian lady beetle, the yellow-fronted bumblebee, the orange-rumped bumblebee, the western honeybee, and the seven-spotted lady beetle are our 5 top observations. But you can also, if we click here on species, it'll show you the whole list. If we click here on observations, you can see everything that's been observed. We scroll down, there's a map. And so this shows you where those observations were made. And so if I was down in Victoria, I could zoom in here and I could click on some of these observations to see what they were and what people there were finding. We also have a journal feature. And so this is, again, if you have your own project, this lets you talk about some of the interesting observations that you've seen and just share a little more information. And then down here at the bottom, we have the most recent observations. So we can see what people have been adding and seeing. And a lot of these you can see are flowers. Most of our observations come in the summer, but some people are still going through their phones, going through their photos and adding things, maybe seeing things they had questions about over the summer. And here's our observation. So let's click that one. And so here it is. And see that it's now actually more specific than it was what I was showing you putting up on my phone. And that's because iNaturalist has another great feature, which is that after you put in your suggestion for what it is, whether based on what you know or based on the suggestions iNaturalist gives me, and that's this. Here I said I thought it was a worm and slug hunter. Another iNaturalist user has actually come along after me, seen this observation, and put in what they think it is. So they're suggesting this is actually the bronze ground beetle, Carabus nemoralis. And so you'll find that this is a really helpful feature, is that other iNaturalist users will help you to refine what it is that you're seeing. And so again, we can see here's the map where it was. We can see when I collected it. And so I just wanted to show you a couple other observations, just to again demonstrate how this can be useful. So that's this one. What have we got here? So this is an observation, a photo sent in by user David Spencer, and it's from somewhere down on the Saanich Peninsula. And this is a leaf covered in these strange stripy beetles. David's put in a note, hoping for an ID. Friend sent me this and called it a Coreopsis beetle. Those aren't common here, however. So he's seeing something, he has kind of an idea of what it might be, but he's not sure if that's right. And so you can see his suggestion for an ID was this family, which are the leaf beetles. But then we've got a series of other people coming in and saying, nope, it's this one. It is Coreopsis leaf beetle. And so we have 3 people all confirming that, yeah, is the Coreopsis leaf beetle. And this is a pest insect that gets into flowers. And we've actually had a bit of an outbreak of it in the past couple of years. And so we've got a lot of people posting this on iNaturalist and saying, what the heck is this? I've never seen this before. Why are these all over my plants? And so knowing that it is the Coreopsis leaf beetle means that you can now go to Google, go to your extension, look for more information and find out what you can do about that. So here's another one. And so here's another photo we have of a flower covered with a bunch of beetles. And so again, we have an observer who's maybe a little concerned. What is this? What's going on? And so iNaturalist has suggested that it might be a soldier beetle. And then other users have come along and said, yeah, that's the common red soldier beetle. And so as soon as we do a little looking, Google common red soldier beetle, what you'll find out is that this is a beneficial. This is a predatory beetle that is actually going to be helpful in taking out other pests. And so rather than being concerned that it's there, it should be celebrated and encouraged to continue to be present. Here's another one. And so we've got this little squirmy, maybe it looks kind of like a caterpillar thing on a leaf. We can see there's a bunch of chewing damage on the leaf. The first instinct a lot of people would have here would be to say, that's a caterpillar. I should be squashing that. I should be spraying for that. I should be getting rid of that. But if we look down here, it's been added to the project. And so because it's added to the project and I'm looking through the observations on the project, I'm able to say, no, that's actually a hoverfly larva. They're a great aphid predator. And we can have this little conversation where Prairie Girl Gone Coastal says, that's wonderful, thanks. And now we know we're not going to squish that. This is, again, a beneficial insect. And just here's another example. Here's this one. Not a great photo, but it's good enough that someone has suggested that it's complex Chrysalopera carnea, which if you look here, common green lacewing. And so again, lacewings are beneficial insects. And so that's the larval form. And you can see it's a predator because you can see these big jaws out the front. And then this is the last one here. So here we've got this insect. What is it? The original suggestion was, well, maybe it's a beetle. But again, we can see here that a number of other people have come in who know what it is, who said, no, that's actually a lygus bug. And a little research will tell you that a lygus bug is a plant pest. So that's how this can be helpful. It's most useful with clear photos, and it's most useful with things that are a little bit bigger. You get really tiny, blurry things, it's not great, but it can be really helpful, especially with noticing beneficial insects and pulling them out and just letting you know that they're actually friends. And I'm gonna pop back into the slideshow. There we go. All right, so once we have this information, we've kind of figured out what the insect is that we're looking at, whether we're using iNaturalist or other ID resources. The next thing that we can do is we can start learning about the biology of this insect. And so I wanted to run us through a couple of life cycles because these are really important to understand how this insect is going to be present on our farms. And we have two types of life cycles. We have a life cycle called complete metamorphosis and a life cycle called incomplete metamorphosis. I'm just going to run you through these quickly. So complete metamorphosis, we think about the kids' book, The Very Hungry Caterpillar. That's this type of life cycle. We start with an egg. The egg hatches out into a larva. In this case, the species we're looking at to illustrate this is the hoverfly. And so here is a hoverfly larva, and it looks kind of like a slug, and it eats aphids, and it's found on your plants in areas with lots of aphids. Once it's eaten its fill, it will create a pupa. And so the pupa looks kind of like a little raindrop on your leaf. And this is the metamorphosis stage here. This is where this insect completely reorganizes itself and emerges as something that may not look at all like what it was as a larva. And indeed, here is our adult hoverfly. And you can see it has wings, it flies around, and it's a flower feeder. And this is the sexually active stage that's going to be laying more eggs. And it's really important to know when you have a pest that has a complete metamorphosis life cycle, or a beneficial, as in this case. And that's because the adult and the larva may be found in completely different habitats, and they may be found eating completely different things and doing totally different things. And unless we understand where all of the parts of the life cycle are, it's going to be very difficult to either encourage more beneficials like this to come or to discourage pests. Incomplete metamorphosis is different. So an incomplete metamorphosis, again, we start with an egg, though some of these give live birth, and we have a young. And the young progress through a series of molts, they shed their skin until they become adults. And each molt is very similar to the one before. So we call these nymphs, the young ones, and then the adults. And there is no big change. The adults and the young are found on the same plants. They feed in the same manner on the same thing. The big difference is that the adults are winged, and so they're better able to disperse, and the adults are the ones that produce more. And so a lot of our plant pests follow this lifestyle. And so these are things like aphids, whiteflies, leafhoppers. These are sucking pests, and they're very effective because they don't need anything else for their life cycle than your crop plant. And so knowing which of these life cycles you're dealing with helps us with managing the pests. And the other thing that we want to be keeping in mind when we're thinking about biology is that both pests and beneficials are present year-round. So even though we tend to focus on them when they're in this annoying, damaging stage, we need to be thinking about what are the other life stages of that pest. So we know that we find this caterpillar chewing on our brassicas, but we need to know that this is the adult. We need to know that it's going to overwinter in infested plant debris. We need to know that other pests may be soil dwelling or have life stages that use the soil. We need to know what the seasonal trends for this pest is. Does this pest like cool, damp weather in the spring and fall? Or does this pest like hot and dry weather? What are the conditions that are going to lead it to increase in population? What are alternate hosts for this pest? Are there other plants in your landscape that this pest is using? And so the more we know about this pest, the more we can change our farm ecosystem to make this pest less likely to thrive. And so here's an example. So I've got some lettuce here, and I have some aphids feeding on that lettuce. And so if we know that aphids have incomplete metamorphosis, and so this means that the adults and the young are all able to feed on the same plant, that lets us know it's going to be able to reproduce really quickly here on this lettuce. We're also going to know that aphids are not great dispersers. They're very slow moving, they're small. And so what will make it really easy for this pest to spread and disperse is if we plant our lettuce like this, next to each other, leaves touching. This provides an easy corridor for this pest to move through our crop with no barriers. And because all it needs is our crop, it's going to do that very well. Now, on the other hand, if we plant our lettuce like this, with other things planted between so that it's more spread apart, what we're doing is we're putting in place a barrier. Many aphids are very host specific. And so that means that an aphid that will infest lettuce will not also infest cabbages. And the aphids that infest cabbages will not also infest lettuce. And so just by interplanting, we create these inhospitable barriers for this pest. The pictures I've put in here for our interplanting are flowers. And the reason for that is that by interplanting flowers within our crop, we're encouraging beneficial insects that have life stages that feed on flowers to move into our crop and be right there where our pest is. And so here, for example, I have one of these tiny parasitoid wasps. They're very, very, very small. We measure them in millimeters. They're not going to fly a long ways from the outskirts of your crop to come in and find these aphids. But the adults are flower feeders. And so here's some alyssum, which has tiny little flowers. Here's some dill with tiny little flowers. And so if we can put these tiny flowers in next to our crop where we're having an aphid issue, it allows these wasps to have resources for all of the stages of their life. The adults will feed on the flowers and they will lay eggs inside the aphids, and their young will develop inside the aphids. And that's what this is. This is an aphid with a tiny wasp developing inside of it. And so these can be very effective at keeping your aphid populations down if you provide what the adults need as well. We also have other beneficial insects that are very effective travelers and dispersers. So things like lady beetles. And so again, if we have things like dill and alyssum and other plants within our crops, pulling these lady beetles in, and then they're going to find these aphids that are inside of the crop. And so we want to have a lot of plants surrounding our farms that support these beneficial insects so that they'll be present and can be pulled into the crops. And so here I have an example of a field margin where they've let things like clovers and daisies and other weeds grow and bloom. So that provides resources for these beneficial insects and lets them start there and then hop over into the crop. And the same thing here. Here's an example of a beautiful hedgerow on a farm that I visit. And so all of these beautiful flowering spaces, and it's a perennial space, so it's a great overwintering refuge, provides habitat for beneficial insects and lets them move in. And when we're thinking about providing that habitat, it's helpful if we can think about native plants. So here's some yarrow, woolly sunflower, pearly everlasting. These are all native plants, and native plants are less likely to host pests and more likely to host beneficials. And that's because a lot of our invasive pests, our pests are invasive. They're not naturally here on Vancouver Island or in Vancouver. So once we've got that biology, we've learned a lot of things, and that now impacts the controls we choose. And so we can use cultural controls, things like resistant varieties, changing our crop timings to match with those seasonal patterns of pest pressure, pruning, removing egg masses, doing cleanups and removing infested plant debris, rotating. We have pests that have a soil dwelling stage. We can use physical controls such as nettings, screens, barriers, traps, even squishing, depending on the scale of your operation. We can encourage our biological controls, find out what will be effective at controlling these pests and encouraging them. And we can use chemical controls as a last resort. We want to use least toxic materials, and we want to use things that are specific. We don't want to be applying broad spectrum insecticides that will kill all of the other beneficial insects that are otherwise helping to keep things under control. So I'm going to give a couple examples of some crops and pests and how we could use these principles to control them. So carrot rust fly. You're probably all familiar with the larval stage of carrot rust fly. The larval stage is soil dwelling, where it will chew into your carrots and it leaves these ugly tunnels full of frass. But the adults are actually flies, and the adults do not live inside of your carrot fields. They'll live in the surrounding areas, and they fly into the carrot fields in the late afternoon, early evening, when conditions are cool. They lay eggs at the base of the carrots. The larvae crawl down and start to feed. The larvae pupate in the soil before emerging as adults. to fly back out of the field. So here we have this complete metamorphosis. Adults and larvae live in different spaces. We also have seasonal patterns. This rust fly is worst in the spring and in the fall. In fields where I monitor for this using yellow sticky cards, we often have a couple of months of rust fly free periods during the hot part of the summer in July and August. Although we really need the monitoring to help us with this, because sometimes rust fly don't do what we expect them to do. We also have some alternate hosts. Rust fly will also use things like Queen Anne's lace, parsley, celery, parsnips. And so being aware of what else is in our surroundings and maybe what's been planted where we're planting our carrots next. And we do have some beneficial insects. So here's one of these carabid ground beetles. These are in the soil and they will feed on eggs and larvae of carrot rust fly. So what are our control options here? We've got a few options. We could think about something like a resistant variety, flyaway carrots. That might help. I haven't heard great success stories with that variety. We could do crop rotations. Knowing that this pest has a soil dwelling stage tells us that it's important to move where we're planting our carrot crop every year. Sanitation, knowing again that it's going to be in the soil. If you have an infested carrot field, don't just leave them there and walk away from them because you're breeding more. And we can also use timing of our plantings. We can use our monitoring to know when the rust fly are not present and delay planting or harvest early when they show up in the fall. And finally, we can use the physical control. We can put a barrier in place. And anytime we have a pest where the larva and the adult are found in different habitats, this is something we can consider. So you can use a floating row cover, such as a remay, or different types of insect mesh netting. And the idea is you put the mesh netting on, the adults will fly and hit the netting and cannot access the carrots and cannot lay their eggs. And therefore you do not have the pest. We can use these same types of control strategies with other pests that have this type of life cycle. So for example, root maggots in onions or brassicas, again, have a soil dwelling larva and an adult that's free flying fly elsewhere in the fields. Let's look at brassica caterpillars. So I've been showing you this nasty caterpillar on your brassicas. So what are we going to do about it? Again, we have to start with understanding our biology. The adults of these caterpillars are butterflies. They're strong flyers. No part of this life cycle is in the soil. And so rotation, while it's very important for brassicas for other pests, is not a great strategy for these caterpillars. The adult butterflies will find the brassicas wherever you're planting them. This pest is present year-round. We can find these butterflies flying from very early in the spring till very late in the fall. And so strategies about changing your plant timings do not particularly work. And as well, using a barrier such as a row cover, in order for that to be effective, it needs to go on as soon as those plants are planted, and it needs to stay on for the entire season. And you have to be very careful that pests don't get under that row cover, where they'll be able to live without any kind of control. So what can we do with this one? So one of the things we can do is we can monitor and know that, number one, the small larvae are susceptible. Those are the stages we need to be targeting. So we can be looking for eggs and larvae. And we also need to think about what part of our plant is important to us. A healthy brassica plant can tolerate some levels of feeding on the leaves. Your customers may not tolerate levels of caterpillar feeding within the marketable parts of the plant. So if that's the broccoli, the cabbage, if it's kale, it may be all of the plant. You may not be able to tolerate any feeding. But being aware of when you can tolerate the feeding and ignore it when it's at low levels and on the plant parts that are not being marketed, and then controlling and cleaning up those caterpillars when the marketable part of the plant starts to form. One of the other things we can do, again, is supporting beneficials. And so this pest, these caterpillars, are fed on by a lot of predatory wasps, such as this yellow jacket. They also host parasitoid wasps. And so here's one of these caterpillars, and this white thing is a wasp larva that has been feeding inside the caterpillar, has just crawled out of the caterpillar and is now spinning a cocoon. And we saw a lot of these in brassicas this past summer. They're quite gross, but that caterpillar is now going to crawl away and die after this giant wasp larva has crawled out of it. And that wasp larva is going to finish its development in that cocoon and then go flying away and looking for more caterpillars. So we want to encourage these beneficial insects. And then if we do need to use an insecticide spray to clean up those brassicas and get those caterpillars out of there, we want to use something that's very targeted. And so, for example, a BT spray will affect only the caterpillars, but it will not impact the beneficial insects or the other beneficials in your garden. And so this is an option for something that you can use. And if you are certified organic, check with your certifier and make sure that you're using a certified organic formulation. But this is a biological insecticide, and so it's derived from E. bacteria, and it's very specific to caterpillars. So if you need to use an insecticide, that's a good choice. All right, and so I'm just going to wrap by talking quickly about encouraging benefit insects and pollinators and what we can do to make our farms havens for these insects, because that's also going to reduce the amount of pest control we need to do. So the first thing is reducing your pesticide use. If you do need to use pesticides, use really specific pesticides that are just going to target your target and not any of your other beneficials. Planting flowers, I'm going to keep hammering on having flowers as part of your operation. These can be things that are also parts of your crop. So here's some dill, cilantro. These can be things like your kale that are going to bolt pretty soon coming up in the spring. Leaving those in the ground to provide those sources. And it can be also be flowers that you specifically plant, such as this goldenrod that's hosting this lovely potter wasp here. And we also need to think about protecting overwintering areas for beneficials. Planting native plants, I've already mentioned. Remembering that some of our beneficials are in the soil, and so reducing soil disturbances. And a big one is being okay with there being some pests. If we have no pests, there's no food for the pest feeding stages of these plants. Here are some ways to incorporate flowers into your farming operation. So we can have hedgerows, along your fence lines, along your farm roads, putting in a diversity of native shrubs, blooming shrubs. This is ocean spray. It's got lots of these tiny little flowers. And I'm going to keep hammering. Really small flowers are really important because some of these beneficial insects, like those wasps, are so tiny. Here is a field of pumpkins, and we've got sunflowers planted all over in the middle of it. It looks beautiful. And again, it's this big showy display. And sunflowers are big collections of very small flowers. And so again, this is going to be helpful for bringing in pests. Here we've got a nectary strip. And so this is alyssum. And this is a strategy of just next to your lettuce, if you've got a big crop field, planting a row of alyssum. And so you can do that. And again, that creates this corridor of habitat moving into the center of your field and bringing those beneficial insects with it. And here's a cover crop of buckwheat. Buckwheat is, again, a flower that attracts many, many beneficial insects. So you can use other things as cover crops as well, but thinking about having something blooming. And of course, you can put in specific wildflower plantings. Again, I would encourage you to use native species. And so this is goldenrod, some asters, and some pearly everlasting. And so all of these things are going to be supporting beneficial insects. And then overwintering spaces, resting spaces, nesting spaces, these are all important. Undisturbed native bunch grasses. And so bunch grasses, they've got this clumping habit. Inside of those clumps provides really great spaces for bumblebees to overwinter, for those ground beetles to have spaces to be protected. Mulch covered undisturbed ground, so protecting our soils with mulches. Those mulches are again providing great habitat for ground beetles and rove beetles and other soil dwelling predators, as well as protecting all the rest of the life in the soil. Untilled, well-drained bare ground. A lot of our bee and wasp species are ground nesting. And so if we have spaces like this and we protect them, that's great. That's a nesting resource. Those species needs to have a nest. They're going to be feeding their young on either pollen and nectar that they're pollinating from your plants or on pest insects that they're catching in your fields. Snags, dead wood, brush piles, these are all habitat features that protect and allow overwintering of beneficial insects, of bees, of wasps, of beetles. Rock piles and brush piles are also great habitat for birds and also snakes. I haven't really mentioned snakes, but snakes are great at eating slugs. And then plants with hollow and pithy centers. So again, these hollow stems are often used as overwintering habitat and as nesting habitat. And this is a PDF from the Xerces Society. And so you can find this, Google Farming for Pest Management Xerces, and you'll get this brochure. And this illustrates the many different ways that you can incorporate habitat for beneficial insects into a farm, and all the different ways you can do so. And finally, the last part of IPM, evaluation. I hope you can take some of what you've learned today and go back and think about what will your farm look like next year? What are some changes that you can make? Some resources I would encourage you to use. So iNaturalist. And then these small scale IPM guides for farms. These are new. They've only come out in the last couple of years, and they're based towards small farms. And they run through these IPM principles. I think there's 12 guides for a number of different pest species. These include things like carrot rust fly, spider mites, aphids and blueberries, powdery mildew, tuber flea beetle. So just a diversity of pests that you may be struggling with, and walks you through the steps of thinking about all the different types of control. And then finally, just some books. This one is a downloadable PDF about selecting plants for pollinators. Garden Insects of North America is a book that I recommend because it has a lot of really great photos of the different pest species that you might encounter, as well as the beneficial species. And it's very beautifully organized in that you don't actually have to know anything about the biology. So you look up plants, you look up pests by where they are feeding on the plant. So you look up leaf feeding pests and you look in the section and look at the photos, or stem feeding plants. And then Farming with Native Beneficial Insects. This is another Xerces Society book, and it goes into all these things in a lot more detail on how to have these beneficial insects present on your farm. And that is what I had to share with you today. And I think we are going to do some questions. Shall I stop the share, Teresa?
Yeah, sure. And at this point, I'll just say thanks so much. That was excellent. I'm really looking forward to using iNaturalist, and I'll just stop the recording now so that folks can ask questions. So thanks, Bonnie, for that.